Welcome to our natural selection model. This is our soil inhabiting almond species. There are two phenotypes within our species, a darker almond and a lighter almond. The darker almonds are more difficult for predators to find because they blend into the soil, while lighter almonds are easier to find. The darker almonds live on and pass down their traits because they are more fit.
Throughout the model, we will be explaining the four principles of natural selection.
Variation. There are different genes or traits present in the starting population. As shown, there are both light-colored almonds and dark-colored almonds. A species begins with an equal amount of 5 of each type of almond.
So the almond species starts out with an equal amount of both traits. We have 5 dark almonds and 5 light brown almonds. The proportion of dark almonds is currently 50%. Each trial represents an entire year, and the chopsticks represent all the predators that prey on the almond species as a whole. Now we will see what happens to them as natural selection takes place.
Don't you dare touch me! Stand back! No! No!
Selective pressure. As time progresses, one trait deems to be more useful in helping an organism of a species survive. The darker almonds blend into the ground soil better than the light ones do. As you can see, it is hard for the predator to see the dark almonds, and thus the light almonds are consumed quicker.
This is an example of disruption selection because the extreme trait of dark color is being favored and continued over the lighter color.
As you can see, after the first year, 2 light almonds were consumed and 0 dark almonds were found by the predators.
Reproductive success. After each trial, there is 1 almond added back to represent the successful reproduction. This is a very high success rate of 100%.
Inheritance. When two organisms go intimate, they reproduce and their offspring retain the traits of the parents. When the almonds reproduce, they pass on their colored traits. The black almonds' children are black, and the brown almonds' children are brown.
After reproduction, 5 dark almonds and 3 light almonds are added back into the population. The proportion of dark almonds now is 62.5% as the second year begins.
Go.
Time. It takes thousands of years for evolution to occur. Over time, the process of natural selection should show that the better, most fit species will survive and reproduce for longer. Eventually, most almonds will be of the darker shade as they are less likely to be eaten. As time passes and darker almonds become more prominent, it may cause overpopulation in which there is not enough space to support all of the almonds. Even though the darker almonds are harder to see, if they are condensed in one area, the predator can easily find them. Thus, there will be competition because there will not be enough space on the ground.
After the second year, 2 light almonds were consumed and 1 dark almond was unlucky enough to be caught and viciously devoured. After reproduction, 9 dark almonds and 4 light almonds are added back into the population. The proportion of dark almonds now is 69.2% as the third year begins. Go. I'm disgusted. After the third year, 4 light almonds were consumed and 1 dark almond was consumed. Before reproduction, the proportion of dark almonds is 81%. After reproduction, the proportion of dark almonds would be the same. As you can see, the proportion of dark almonds in the population increased by 31% over 3 years.
Eventually, the species as a whole adapts to the weakness of the predator to sense darker color in the dark soil naturally.
We can expect that over a larger amount of time, the proportion of dark almonds will approach 100%.
As you can see, over time the species as a whole evolves through natural selection. Due to the continuous selective reproduction, the proportion of almond offspring that has the preferred trait darker color will increase. The whole species will approach a point where most or all of the organisms of the species are dark as all of the light almonds die out.